Hello everyone, welcome to this class. In this class, we're going to solve for equation involving fractional indices, how to solve for the variable. So let's start. Now we have x raised power 1 over 3 is 4. This x raised power 1 over 3, if we put it in normal form, it will be cube root of x is giving us 4, right? How do we now find the value of x? Simply, we find the cube of both sides, do something like x all raised power 3. So that these 3 will cancel this 3 and it will remain x. So x will now be, okay, this is 4 raised power 3 too. 4 raised power 3 is what? 4 times 4, 16. 16 times 4, 64. So this is your x. This is your answer. So let's solve the next example. The next one is 2a raised power minus 1 over 2 is equal to minus 14. Now remember, this minus 1 over 2 only applies to this a. So let's start solving. First thing we are going to do is to make this a to be on its own. So we'll divide both sides by 2. We are going to have a raised power minus 1 over 2 will give us minus 7. Are we together? So the next thing we are going to do now is this a raised power minus 1 over 2 is the same thing as, because there is a negative sign here, the same thing as 1 over a raised power 1 over 2 is the same thing as, which is equal to minus 7. So is the square root of 1 over a is equal to minus 7. So what we need to do now is square both sides. Square root of 1 over 3, 1 over a all squared equal to minus 7 all squared. So when we find the square root of this, we just get 1 over a is the same thing as minus 7 squared is what? 49. Right? So when we inverse both sides, we divide both sides by 1, or anyhow you want to say, you flip this side and flip this side, you just have a is now 1 over 49. So this is your answer. Hope you understand what happened here. Because we have 1 over a here, you understand? I just said let's divide both sides by 1. I can say something like 1 over a equal to 1 over 49. At the end of the day, this will give birth to a. Why that will give me this. So let's solve the next example. So this is exercise 1F number 7. Now, instead of us going through, I will solve this thing with the long process, and this will be the last time I will solve with the long process. I will now give you a shortcut you can now use to solve complex values like this. Let's go about it. Here we have, if we are to change this, the negative sign will first make this 1 over n all raised to power 2 over 3, which is equal to 9, right? And this is the same thing as cube. Okay, I'm getting something. Okay, cube root of 1 over n all squared is equal to 9, right? Now, to remove this value here, we will find the square root of both sides. This will be square root of, here, find the square root of square root of this 1, and of this is 3, cube root of 1 over n all square equal to square root of 9, right? So when I find the square root, these two will be cancelled out. So I will now have only cube root of 1 over n. So square root of 9 will give me plus or minus 3. Remember, it's an even root, so don't forget your plus or minus. So the next thing we are going to do now is find the cube of both sides. So I will cancel out these 3. We have something like 1 over n cube root of 3 all cube will give you plus or minus 3 raised to power 3. So this will cancel this. I will now have 1 over n is now plus or minus 3 raised to power 3 is 27. Now to find n, we flip both sides. 1 over this is equal to 1 over that. You now have n is plus or minus 1 over 27. Now this is like the long process of solving this. Now let me give you a shortcut you can now use to solve things like this. Let me solve it beside it here. You have something like n raised power minus 2 over 3 equal to 9. Right? Just simply look for that number that when you multiply here, you get 1. And whatever that it is that you multiply to this power, you get 1. Multiply it to the power here. So what is it that we're going to multiply to get 1? It will be n raised power minus 2 over 3 times minus 3 over 2. You see, I now look for the inverse. So that when 3 cancel, it will give me 1. 2 cancel, 2 cancel, it will give me 1. Minus times minus will give me 1. So I do the same thing to the other side to be 9 raised to power minus 3 over 2. So after solving this, you now have something like n, because everything has cancelled out to 1. It's now giving me 9 raised to power minus 3 over 2. Very simple. Instead of going through this long process, just look for what you multiply at the power to give you 1. That value, whatever you whatever you multiply by the power, whatever it is that you get, raise the other side of it to that power. So when you solve for this now, n will now be square root of, because of this minus, it will be 1 over 9 square root all raised to power what? 3. I just jump step. I just get we understand. The negative sign made it 1 over 9. The 2 made it the square root, while the 3 made it the power that you are raising it to. So n will now be, when you solve for what is in the bracket, you have 1 over 3. But because the here is an even number, plus or minus is already here, all raised power 3. So n, when 1 over 3 times 1 over 3 times 1 over 3, have plus or minus 1 over 27. You are getting the same answer that you get here. So instead of going through this long process, you can just use this shortcut. Look for whatever. When we solve for the next example, I also apply it there. So let's solve for this example. X raised power minus 1 over 2. Just what are you going to multiply this to give you 1? Just the inverse. It will be x raised power minus 1 over 2 times minus 2 over 1, right? 2 will cancel 2, 1. 1 cancel 1, then minus times minus. So you have that 2 over 1 is what you are going to send to the other side. It will be 5 raised power 2 over 1, which is equal to 5 square. So now x is equal to 5 square, which is equal to 25. Very simple. Very, 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 very simple. Let's solve number 9. Number 9 says 5x is equal to 40x raised power minus 1 over 2. Are we together? So for this case, we'll try to first divide both sides by 5. We have something like x is now 8x minus 1 over 2. Are we together? So the next thing we are going to do is let x be one side of the equation. So I'll divide both equations by x. If I divide both equations by x, I'll have 1, because x over x is 1, is equal to x, 8x minus 1 over 2 all over x. So then push this to this side to be 8x minus 1 over 2 all over x equal to 1. Right? So divide both equations by 8 so that only x will be at one side of the equation. We have, first let me translate this to what it should be. It should be 8x minus 1 over 2. Right? I'll bring this x up, it will be minus 1 because it's division. So the power 1, the dividing by the power of 1, so minus 1, which is equal to 1. Right? So this will be equal to minus 1 over 2 minus 1 is sitting as x minus 3 over 2, which is the same thing. That's 8x minus, which is same thing as 1. The next thing I'm going to do now is divide both sides by 8. I'll now have x minus 3 over 2 is the same thing as 1 over 8. Now let's apply that our shortcut. Look for what you multiply here to give you 1. you have something like x, the inverse, minus 3 over 2 times minus 2 over 3. This is what you are multiplying it. So when this multiply this, you are getting x, 2 cancel, 3 cancel, 1, minus, minus, plus. So you are getting your x back, only your x. At the same time, this 1 over 8 will be raised to power this thing you are multiplying it by 2 over 3. So this will be x. If I'm to open up this, if I'm to remove this minus, it will now be 8 raised to power what? 2 over 3. So let me start solving from this side of it. Also have it on one page. I'll take this up. It will be x raised to power s equal to 8 2 over 3. So we'll now apply our law of indices. 3 will be the root, y2 will be the square. So x will now be 8 cube root and square. So x will be cube root of 8 is what? 2, or squared. Remember, there is no plus or minus. This is odd number. The 2 is a real answer. So 2 squared, now x is now giving us 4. So just apply this shortcut instead of going through the long process, this long process here. Just apply shortcut. Look for when you have something like this, something of this nature, look for that value that you multiply this power to get. So here will be 1. The other side of the equation, multiply it by that same value. I'll just solve for one equation and I'll call it. This will be the day for this class. Number 12. I have 4c1 is the same thing as 64. There are cases where you have to reduce it to the lowest number. I think this is one of those cases. Are we together? So here, what's the lowest number here? 2. Both of them 2. So this will be equal to 2 because 2 times 2 is 4. Then the 2 will come up and multiply whatever that is here, c minus 1. This will be 2 raised to power what? 6. 2 raised to power 6. 2 times 7, 6 times will give you 64. So this is what we'll now start solving. We are solving for c, right? So now, since these bases are the same, it simply means that this power are also the same. So 2 raised to power c minus 1 is the same thing as 6, right? C minus 1, when we divide both sides by 2, we get 3. Therefore, C is equal to 3 plus 1 when 1 cross equation. So C is equal to 4. This is your final answer. So this is examples involving fractional indices. The take home we are going to take here is that when you have, let me give you an example. When you have something like x raised to power b over a is 1, find x. Look for something that you multiply this to give you x raised to power 1, and in this case it will be x raised to power b over a times, just find the inverse, which is a over b, right? So just make 1, though we are using 1 here, but let me assume we use 2. So let's make it 2 raised to power a over b. If it's negative here, add negative, so everything will cancel out to be 1. Instead of going through the long process, this is the easiest way you can solve for fractional indices. But mind you, before you start solving this, you must have finished all your division of the normal numbers, finish all your division, multiplication, whatever. Make sure that x is alone in one side of the equation and numbers are alone in the other side of the equation. Thank you, and see you in the next class.